based in Dublin. We were formed in 2005 as a spin-out from Trinity College. We see ourselves as a data science technology company. So we try to solve problems using data science, data curation, collaboration using data, and creating models. And almost all of our work has been on food and public health analysis. We have a number of models that are available from food safety, nutrition, crop sciences. We're working with the EPA here on the next generation of the cumulative and aggregate risk assessment model for pesticides. Care and cosmetics, we've worked a lot with the Research Institute for Fragrance Materials in New Jersey, looking at aggregate exposure to fragrance compounds from all sources, including personal care and cosmetics. And we're doing a lot of work in microbial. So a lot of our work has spanned the whole food supply, from the farm area, looking at things like pesticides, to the processing plant, where contamination and additives and processing aids can be added to food. Foods can be formulated for better health, and we've been looking at the impact of that using our Creme nutrition model. In terms of packaging, the FACET project here is one I'm going to focus on a little bit, where we did a lot of work in Europe under EU Framework 7 project to create a model of consumer exposure to packaging, which combined migration modeling and detailed food consumption data for Europe, which has its challenges, obviously. Following that, we do a lot of work in dietary data collection and onto the impact, the human health impact, using nutrition models or food safety models. So in this talk, we're looking at food packaging, food safety, exposure. And I'm going to move on then to a new project called GLOPACK, which is funded in Europe under Horizon 2020, which is covering all of the food safety issues of packaging, but also the functional benefits around packaging and innovation. So what packages are good for different types of functional applications? How can you know that? How can you model that? What data can we collect to help people make better decisions around the right packaging types that they can use, which will have the functional benefits, but will also be safe and will maintain the quality and the safety of the food products that they want to use that packaging for. And all of this work is done through a data science platform called Expert Models. So talking about packaging safety and exposure modeling in particular, I'm going to start with the FACET project. So it was funded under Framework 7, and it was focusing on flavorings, additives, and food contact materials. The food contact materials did take up the largest portion of this project, so it was very focused on that. And we spent a lot of time gathering data from industry. And again, the whole problem with the food packaging industry was that the finished product manufacturers, the brands, I guess, using these food packaging did not know what the chemicals and compounds were in those packaging. And even if they went back one step in the supply chain, the people selling them those packages did not know, because they were not told what was in that packaging by the people making the big tons of rolled plastics that got turned into bottles and packages. So there was a very interesting challenge to kind of create a secure data portal where all of these people or organizations in the supply chain could securely and anonymously, I guess, upload information on their packaging types, the chemicals they use. And we've done this across a number of industries, where we allow organizations to securely submit data without disclosing maybe the exact formulation. So one way to do that is to let them submit a small range. Well, they use this particular compound in this packaging. They don't have to give us the exact concentration, but they gave us ranges. And those ranges were tight enough for us to have very, very detailed exposure models created and migration models, but they didn't have to give away some of their proprietary trade secrets where they were concerned about that. So overall, the project was quite successful. It resulted, these are the goals here of the project. I've just highlighted the one in green, which was the core work that we were doing, but there was lots of other work package leaders around Europe looking at all of these other aspects of the project. So we needed to understand the food intake, the packaging use levels in food, and that was done through market share companies. The food intake around Europe is very diverse. Different countries measure food intake in different databases and different coding systems. So we had to harmonize that. We had to look at all of the different migration modeling questions, and worked with some experts in the Fraunhofer Institute who really know their stuff on migration testing and migration modeling. And I'll talk a little bit about that. And then at the end of the day, we needed to combine this into a useful software tool that industry can use. So our role was twofold: regional modeling, which was that harmonization of databases of food consumption around Europe, and the actual modeling of those databases in Work Package 8, which was the creation of those tools, working with the migration experts to connect in the migration part of the model, working with all of the databases that we gathered from the supply chain of food packaging in Europe and the food consumption databases in Europe to bring that together into some kind of useful tool. So we've heard a little bit, quite a lot about migration modeling, and this is I suppose this is well understood these days, how to model migration through packaging. And we can see here this is kind of a multi-layer system, and the sink medium is ultimately the food in our case, but this is a fairly well understood physical process. So we have two important concepts: the diffusion parameters, which are applicable to each layer in the system, and in food packaging, even the standard coffee cups that you get that you think might be cardboard, of course, have cardboard and plastic and inks and lots of different things. So we can consider most packaging types to have multi-layers. Each layer has a partition coefficient, and that basically, as all of you are probably well familiar, quantifies the likelihood of something passing through that partition. Okay, so we're interested in this. This is the equation for the diffusion coefficients, and this is based on the work of Pringer and Branch, who are the partners in the project. And the hard part, I suppose, for this is not the equation itself, but getting the parameterization of that and understanding the chemistry of these package types and being able to parameterize these types of equations correctly in order to make the model effective. So we can see there's aspects of this model that are specific to the material, and then aspects which are specific to the model molecular weight or substance specific of the substance that we're interested in that may migrate from the packaging into the product. And then in terms of partitioning, the KP, P, and KP of the sink material are dependent on, obviously, temperature and the nature of the substances themselves. So temperature affects this. And when you model that, if you start out with all of your concentration in layer 1, in this case, you can hardly see it there, but it's the line, there's a dark line that shows it. And as time goes by, depending on those parameters, the chemical will start to migrate through the layers and possibly into the food itself. And over time and temperature, this will start to form a sort of an equilibrium and settle down to a particular equilibrium over time and temperature. So these are the types of migration models that we then connect into the supply chain. So we know a lot about we now know the compounds in the plastics. We know the substances of interest, and we can calculate this. So we can now know what is going to end up in the food. The next step clearly is then to say, well, what is the actual exposure to consumers to this concentration from the food? So we got the data for these compounds and package types that we then worked with the Fraunhofer Industry and other Institute and others to parameterize those equations using secure data portals. So these kind of portals we've used a lot in various projects, including fragrance data collection, where we've collected over 2,000 fragrance compounds used in personal care products and how they're used in finished products, but also in this packaging project where we wanted to connect into each level of the supply chain and understand, well, what are the materials you're using at the raw production of tons of this rolls of plastic? What are those plastics then used for by the next level? What are the sizes and shapes of those packages then produced? And then who uses those packages for what food products? So connecting all of that is quite a challenge, and each part of the supply chain, as I mentioned, may not want to disclose all of their information to the next level, and they're very sensitive about that data. But fortunately, through the stakeholder engagement in the FACET project, we did manage to get really good engagement from industry, and they did actually share an awful lot of data. So the FACET database now does contain a lot of data on this, on the materials manufacturer, from the manufacturing companies, from the packaging manufacturers. We have market share data from the project time, which is a little bit out of date now and should be refreshed obviously over time. And then information on who's using those package types for what food types. Okay, so all of this data then gets anonymized into the model. So when people actually run these models of exposure and migration and combined with exposure to get exposure to consumers, they're using all of this data, but they're not able to see the raw data of each part of that supply chain. So they can get the information on chemicals migrated to food, for example, here on the right, and they can get detailed data on that using all of this data, but without seeing the elements of the particular inputs into that calculation. So in terms of consumer exposure, I'd like to talk a little bit about this because this is something we do a lot of. We try to use the full food consumption databases and habits and practices in our models, which then translate to being able to understand exposure of any detailed demographic group you may be interested, adults, children, males, females, age groups, etc. So food consumption databases are available all over the world. In the US, obviously, you have the NHANES database. In Europe, we have various countries collecting various different food consumption databases. And in FACET, we had to bring this together into one European-wide food consumption database, which still, there is no good one source of detailed food consumption data for the European population as a whole. FSA does have that data, but they don't make it publicly available. They just make summary statistics publicly available called their FoodX statistics. But we like to use the full food consumption database. And what we do then is we install all of this data, and ultimately we're trying to figure out, well, what are people eating? And that comes from the food consumption database. What chemical levels are in the food? And in this case, that comes from the full migration model, which we've calculated using the different use cases and the different scenarios on the food packaging. So we end up with chemical occurrence in food products as a result of our migration modeling. So once you combine the food consumption data using the correct connections between foods and packaging types, you get a distribution of exposure across your population of the chemicals of interest in the food. So we're able to go right from a particular substance of interest right through the packaging database, right, combining that correctly with the food consumption database and getting a detailed distribution of exposure. And how that works is we have representative population level data. This is like based on the census. It's like when they do the polling for elections, they only need to sample a few thousand people and they can ask them who they would have voted for, and they can predict what the whole country is going to vote for. So in America, they have about 7,000 people in your NHANES database, and because they're selected cleverly based on demographic groups and to be representative based on your census, etc., actually the food habits of those 7,000 people represent the US food consumption habits and practices very nicely. And the NHANES database is a great resource. They refresh it every 2 years. And it's publicly available. You can access it. It is quite complex, and that's where models like this make it much easier then to use those data. In Europe, we have exactly the same thing. So in those databases, each individual of those 7,000 people has recorded their diet, every single eating event they had over 2 non-consecutive 24-hour periods. So we know what they've consumed. So this person one here on day one has eaten various foods. We know the amount they ate in grams. And what we want to do then is combine that with the concentration data. And this is simulated or modeled, not simulated as in the simulants of your migration testing, but simulated as in calculated from our migration modeling in terms of, okay, well, they've eaten this food. What was the likely package of that food? What was the likely migration of the compound of interest to that food based on the types of packaging we know of in our database. And we do that for every single eating event, which would have a couple of 100,000 records for those 7,000 people. So we do that for every single person, for every single eating event. It goes through their day one, day two, off you go, and then you get a daily average of exposure for each person in your population. So now you know of these 7,000 or so people, every single person's actual exposure to that substance you're interested in, based on your migration model and their foods as consumed. And of course, some will have a low exposure and some will have a higher exposure. And this could be based on many things, the choices of foods they had, whether they were fortunate or unfortunate in the assignment of the type of packaging, because that would have been done probabilistically during the model, and they will get a certain exposure. And then you will calculate things like the mean, but more importantly, the P95 or the 95th highest consumer. So often in these exposure models, we use a P95 to represent a high consumer, because we want to understand not just the average consumer, obviously, but the people getting the highest exposure. When you look at a histogram of the exposure in milligrams per kilogram per day, you'll see a kind of a bell-shaped curve. And if you relate that back to a hazard or a toxicological limit, say an acceptable daily intake or a tolerable daily intake, you might see that certain people have gotten exposure above that limit. And you can investigate that and check what was driving that, what foods were driving that, what package types may have driven that, and then actually make decisions around, reformulating the choice of packaging or changing the way that your foods are packaged, etc. You can also look at things like, what type of people are they? Are they young? Are they old? Etc. And understand if this is a health issue. So the data for those food consumption surveys comes from various, 10 minutes, okay, thank you. Various European food consumption databases, and as the FACET project put those together, it actually created a representative EU population. So deploying that in a software tool then, all of that data and modeling capability was packaged up into a user-friendly tool, and this is available on the European JRC website. The data is a little bit out of date because the project was completed probably 8 or so years ago, and the data hasn't been refreshed, but it is a very useful tool that you can look at. You can click through the chemical compounds, you can run some analysis and look at some exposure results across different demographic groups. There was various publications, a lot of publications from that, and you'll get the slides afterwards, so you can have a look at these. Some of the key publications here are in food additives and contaminants and food and chemical toxicology. And since FACET ended, we've used some of these migration models on other aspects. So for repeat use plastics, for example. So FACET was fully focused on food packaging, which is a one-off use. But these models, of course, can be used for repeat use. So with sustainability and reuse in mind, we've done a little bit of work on looking at how we can modify these types of migration models and exposure models to look at aspects like food preparation, chopping boards, food storage, lunch boxes, and things like that. So in one example, on Ergonox 1076, which I saw mentioned yesterday, we looked at lunch boxes, and in this case, how over multi-use, and including those lunch boxes going potentially into a dishwasher or into a microwave or whatever, how the chemicals may end up migrating into the contents. So there was a decision tree framework put together, again based on food consumption, the probability of different articles being used for storage of those foods, the probability of what those storage containers were made of, and the components of those. And the interesting thing, I suppose, was that over time, these products, as they get used, get safer, because whatever leaching would have happened in the early days, as they go through dishwasher cycles and use and reuse, the migration settles down to ultimately zero over a period of time. So there's a good news story, I suppose, there from a sustainability point of view and from a safety point of view. Finally then, a current project that we just started, we're about a quarter way through a 4-year project called GLOPACK, and this is trying to combine all of that safety exposure research with some further information on to aid decision making on sustainability and innovation of packaging. So this is currently ongoing, and we are the data science, I guess, partner in this project. So we're using our expert models platform to curate and aggregate all of the data from this project. GLOPACK stands for Granting Society with Low Environmental Impact Innovative Packaging. You always need a good acronym for European projects. I think it's 80% of the battle if you get a good acronym that you've kind of got past page 1 and the reviewer is still reading your proposal. So we're not the coordinator, so we can't take credit for the acronym, but we are a partner, and it got funded, so we're happy with that. And again, a multi-stakeholder project where we're trying to understand not just the safety and health aspects of food packaging, but strategies for reducing the environmental impact and accelerating that transition, as we spoke about a number of times over the last 2 days, to the circular economy. We're hosting all of the mathematical models and data and a decision support system on our expert models platform for the partners, but ultimately this will become available at the end of the project for collaborators like yourselves. And so we'd love to get feedback on that as we go through. And we're only, as I say, a quarter way through at the moment, but in a couple of years, or a year or so, we'll have a pretty well-defined prototype. Here's some of the models we're looking at, and here's the kind of things we're trying to model and, thank you, figure out from these models. And these were selected by the consortium as important things. So these are existing models, but they're, I suppose, like a lot of models, they're built by some research group, and they're available or they're not available, and they're not maintained. But the concept here is that we'll bring them all together into a user-friendly space that can be kept up to date and maintained, and combine all of these intelligent models into one toolkit that helps industry make better decisions around food packaging. So the first one there simulates oxygen within the headspace of sealed packaging. The next one is all about the growth of organisms within a sealed package based on the oxygen and carbon dioxide. TELOPACK, looking at the initial concentration of gases to optimize microbial growth retardation. So again, optimal packaging for shelf life and quality maintenance of food. The next one is about the scavengers that you put in packaging that will simulate the O2 in the presence of O2 scavengers, so trying to keep the O2 levels down in packaging using scavengers, and then having models that can tell you this will work well for your product, your food, and what you should expect from that packaging. The FACET models are being brought into that, so that all the migration modeling to make sure that the migration and chemical migration is safe. And EcoBiocap will be ranking packaging materials based on other user criteria. There will be other aspects into this decision support tool, like costs and other things like that. So you'll be able to kind of search for various packagings with functional specs, but also at a whatever price point that will make sense to you. So here's the existing Predox pack, which we'll move over to our platform. Here's some of the results it can generate: O2 in headspace, CO2 in headspace, and Pseudomonas growth, for example, over time. You can see those 3 graphs there. So they'll be moved onto our expert models platform. And this is a platform that we have spent a lot of time developing. And we kind of like to think of it like Google Drive for data science. So we've put a lot of time and effort in making this very user-friendly and deploying data sets, while curating and deploying scientific data sets into this system as read-only, so our users can access them, but they can't interfere with those data sets. They can use those data sets in models. There's a number of models in there already. The GLOPACK models will be added in. The GLOPACK models will have this type of decision support information. Very hard to read, sorry. Maybe when you get the slides you can see them, but it looks at things like the functional parameters, the headspace information, the packaging requirements around cost. You fill in all of that, and it will come back and run all of these models basically, and come back and give you recommendations on appropriate and suitable packaging for your use case. And that's it. So I'd just like to say it's been a really amazing 2 days, day and a half here. From what I've learned, I suppose, and I was asked to make a few closing comments, the food packaging safety and sustainability are huge challenges and very important issues for us. And I think the quality of the science and the talks that we've had, we have really the right people in the room here, which cover all of the aspects from the chemistry, the toxicology, the lab testing, the mathematical modeling. We talked about some machine learning, the data science that goes into it. And I suppose when you have a hammer, I suppose everything looks like a nail, but for me, data science is that hammer that is a powerful tool to try to help bring all of this science together into a user-friendly way, and tools and models are my way of seeing that. And finally, I was really struck by the first talk yesterday by Roxy, and we need to try to communicate all of this better and cross over the mountain to see other people's point of view. And I think technology and apps can help with that. So thank you very much.